You know what I love for persisting my entities? No, not JPA. I'm sure it's fine. It's just never been my favorite thing. For starters, it optimizes, in my estimation, for the wrong thing. I think the Hibernate team and the JPA people would tell you that Hibernate is great when you have lots and lots of relationships, which is typical. I mean, it's common enough that, yeah, I can see why that would be useful, but I don't think it should be common, right? If you're building an application with hundreds of tables, then yes, you're going to benefit from some of that automatic relationship reconciliation that you get in something like a Hibernate. But why do you have that many things in the same code base in the first place, right? To me, that's a code smell. So having a tool that makes doing that thing, the wrong thing, easy isn't in my book. I would optimize for something else, right? And ease of use, speed, convenience, conciseness, performance, all these things I would think are top of mind. So I just think there's other alternatives. And you've heard me talk at length in a number of my different Spring Tips videos. I looked at my betas. I looked at Java OOQ and Java Object-Oriented Query. I looked at a lot of things. And today I just wanted to take a brief look at the thing I seem to be using more and more these days, almost always. I even looked at Exposed, which is a Kotlin ORM, very nice, type-safe Kotlin DSL and so on. There's lots of good things. A lot of these tools actually have one thing in common, which is type safety above all else. So Java OOQ and Exposed both give you a type safe DSL, one through code generation at compile time and the other one through the Kotlin language and APTs and the like. But either way, very, very powerful. But one thing I've been using a lot of late is Spring Data JDBC. I quite like JDBC. I have never feared it. And frankly, now that we've got Project Loom and virtual threads, there's no scalability in degradation there by using JDBC. I mean, I like R2DBC just fine as well for reactive. But the point is, straight SQL, no matter how you access it these days, is probably fine. You probably have other things that'll frustrate your application's ability to grow sooner than your database and your database driver, right? So for most applications, JDBC is just fine. SQL is fine. And if you really want scalable SQL, well, my goodness, you don't have to be told twice about all the amazing things that are out there to support that. I did a whole Spring Tips video on Yugabyte DB, which is a Postgres++. It's Postgres built by the same people that built HBase and Cassandra. So these are very, very scalable data stores, and this is no exception. Yugabyte is meant to scale, horizontally and almost infinitely, linearly. So, you can get regular SQL-like behavior in a data store that scales out like something that would serve almost all use cases short of, let's say, Facebook or Google, right? And for everybody else, you're probably just fine using Yugabyte. So I like SQL. There's no reason to be afraid of it for 99% of our use cases. So we're going to go ahead and build an application. 3.2, thank goodness. Java 21. We're going to call this Beautiful JDBC. And we're going to bring in the GraalVM native image support. We're going to use Spring Data JDBC. We're going to use Postgres. I just want the Docker Compose file to keep it simple. And we've got the GraalVM native image, Spring Data JDBC, Postgres. Anything else? Is there anything else? I guess not. Let's just keep it simple. We're just going to have a simple repository and a simple, client that talks to that repository. We'll hit generate. Go to the command line here. Oops, I inadvertently downloaded 2. Okay, here we are. UIO jdbc.zip. Open that up. Okay, and there's my program. And you can see I've got compose.yaml there. And it's going to give me a default username, password, blah, blah, blah. The only thing I'm going to do here differently is I'm going to expose the port. And I'll go to the command line, docker compose up, docker ps -a. And it's complaining that I've already got something running. That's fair. So let's go ahead and stop it. So is this the one? Docker ps. This will be the one. Here we go. Okay, good. Let's do docker compose up. Okay, it's up and running. Great. Fantastic. Now we have to connect to this. So it's my database, secret, and user. Okay, so application.properties, Spring data source URL, my secret and user. Okay. And URL JDBC PostgreSQL localhost my database. Is that right? My database, secret, and user. Looks okay. So let's go ahead and now start the program, or at least start thinking about the program. And let's just start small. JDBC application. All right. So what I'm going to do is I'm going to build an application that manages some data. Okay. So the very first thing I'm going to build is some SQL files. So I'm going to create a SQL file. I'll go to my resources here, source main resources. Create a new file here called schema.sql. And we'll just paste all the schema in, okay? And so the schema is basically create the table if it doesn't exist, customer, create another table if it doesn't exist, customer orders, and create another table if it doesn't exist, customer profiles. Okay, and the DDL is pretty straightforward for all of them. You can see I've got each one has a primary key, ID serial primary key. Each one has some data in it. So this is a text for the customer, which is name. We have a name for the orders, the product, I guess. And then each user has a one-to-one relationship with a customer profile, okay? And I'm going to delete from both of them just to make sure that we're always constantly starting up with 0. And then, let's just start modeling the code, okay? So first things first, what are we going to do? Well, you can surmise by looking at our DDL that the central type in our aggregate is the customer, okay? So we're going to create a repository here for a customer. So customer repository extends list CRUD repository managing customers whose primary key is of type integer. Okay, and what customer, you might ask? Well, this one, customer, integer ID, string, and then what do we call the, it's called name, right? So string name, very good. And we're going to annotate this with @ID. Already, this is a really nice thing. So I'm using read-only views of the data here. Great, it's just, for a lot of use cases, this is what I want. If you want stateful applications or stateful entities, then yeah, use a class, it's fine. But the fact that you can use records and it does the right thing in a lot of the cases is really nice, because this just becomes very simple to understand, right? Okay, so now I've got the customer and I've got the repository. I guess let's just try it out. Already we've got something working with Spring Data JDBC. One of the nice things about Spring Data is that if you're using any of it, then you're going to be familiar with the rest of it, right? So let's see, repository.findAll, args repository.find all.forEach, print out the results. And I'm just going to run the application. I'll start it up. Here we go. Okay, so something is wrong. Oh, this. Okay, run again. Okay, did it work? Did anything happen? Did it connect? Who knows? It is complaining because, why is it complaining? Bad SQL grammar. Uh-oh. So select customer ID as blah, 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 as name from customer. What did I call it? Well, I called it customer, okay? So it's got ID and then name. ID, name, great. We didn't tell Spring Boot to initialize the database, so the schema doesn't exist. I'll add this property, restart this. Take 3. Okay, there we go. Did that work? We don't know. There's no data. Of course not. So let's write some data to the database. Okay, and we're going to create our simple record. So we're going to say repository.save new customer A. Okay, bar customer equals that. Restart. There you go. So we did the search. We got the results back. Fantastic. That's nice. Okay, so now pretty straightforward. It's just a simple entity, keys and values, one row, one table. Easy, easy. Okay, let's see if we want to get a little more involved though. Let's say we want to also now start accounting for a one-to-many, a one-to-one relationship even. Okay, so now every customer in turn also has a customer profile. Okay, so I'll create another type here called profile @ID, integer ID, string username, string password, okay? So again, this is like social media information. So the customer is the actual entity, but their profile page and all that stuff, maybe that's described by this. So I want to map that. I want to include that as part of my object. Okay, so I'll go here, profile, okay? So now I've got to update this code here. Got the name. I also now need to include the profile, okay? Null. And then user, and then password. Okay, don't ever name your code like this. Okay, so okay, let's just run that and see what we get. Okay, what happened? So it's saying the profile table doesn't exist. So we have to use some custom mapping annotations here from Spring Data. I'm going to say customer profile, right? So if you go to schema.sql, you can see it says customer orders, customer profile. Maybe we should make that profiles to be consistent. Okay, so close that, go back to this, add an S, restart. Okay, look at that. So now You can see the profile got its own ID, username and password. Didn't have to do a lot, right? Still, we can, and you might be wondering, well, gee, like if it's Spring Data JDBC, where's the JDBC? And for the common stuff like this, there is none. You're rocking it. You're fine. It's all good. You can get fancy. You can change this repository, for example. You could have like a, let's say, collection customer. You know, you can even do things like find by name, string name, and behind the scenes, this will also work too. But the nice thing is that you can do query, right? So you can do, and remember, we have multi-line strings now in Java, so you can do things like, you know, select all from foo, bar, where, whatever. You can do all sorts of really fancy things there to inform the response that you get back from that method there, okay? Okay, so we've got that find by name. Maybe I changed it. Maybe I do this. Let's do repository.find by name, and the name is A. So I'm going to print that out as well. Okay, here we are. Voila, restart. All right. So what happened to this? Oh, I put myself in an inconsistent state because the DDL is not correct anymore. I added an S and I forgot to reflect that here. So let's go ahead and run the program again. Okay, there we go. It's worked. Fantastic. So now we've got the customer and the profiles, right? And you can see it's returning one as a part of a collection of all the records, and the other one is just responding to the custom predicate we've got there. Okay, so we've got a one-to-one relationship. Not bad. We're not doing anything particularly smart here, by the way. You know, you could probably see what it's doing by changing the logging. So logging level org spring framework data JDBC equals debug. Restart the code. And do we actually see the information about the SQL query? Create if not found using the query lookup strategy. No, we do not. That's pretty sad. Is there any way to see that? Is there any way to see that? Maybe I can just do JDBC equals debug. Let's see what that gives us. There we go. So you can see now the actual queries that are getting passed in and so on. So select customer ID, blah, blah, blah. As name, profile ID is blah, blah, blah. And you can see it's doing some left outer joins there. That's pretty smart. It's not as sophisticated at the end of the day as what you might get from something like a Hibernate, but for this kind of a common one-to-one relationship, works just fine. Okay, I can hear you thinking, what about a one-to-many? Well, here, friends, things get a little bit more fun, but not really. Like it's basically the same thing. So let's just create another type here. And this time we're going to create a order. Okay, so for each product. And it'll be ID, integer ID, string name. Okay, and this is going to be, as before, customer orders. Okay, now how do I map this? In my customer? Well, if you just guessed, I put a collection in there and just call it good. You're right. So set order orders. Okay. Voila. Okay. Remember, we've got the schema here. So we got customer orders, and we've got the pointer to we've got a foreign key pointing to customers called customer. And so here's the customer ID, and then we've got a foreign key in the many side of the one-to-many relationship. We've got that. What else? Okay. So now we've got this. Let's actually create our orders as well. Here we go. So is it here? No, it's at the end of this thing. Okay, so profile set.of new order null A new order null B order. Okay, let's just name it like that, so it's a little bit more clear. In fact, I think it's getting a little cluttered. Let's just extract this out to its own little variable so we can kind of see what it all portends. Good. All right. Nice. Okay. So there's this. There we go. There's our two things. We can just run this. And now, ta-da! Orders 1, orders 2 in the collection, right? And so if we visits pSQL, let's go to the command line here. pg password equals secret. psqlu my user h localhost, and then what is it, database, or what do we say, application.properties, my database. So my database. Okay, select all from customer. That was special. Customer orders. There we go. It's worked. It automatically manages those relationships for us. Okay, so it's doing the real work that we want it to get done. For a lot of applications, especially if you're just building a microservice and you've got a handful or a half dozen or whatever, or maybe even a dozen entities, and you just want them to work nicely, well, think about this. This is really, really fast, right? Really, really fast. Spring Data JDBC is like, I don't know, if you're just, try it actually. I mean, look at the code. First of all, I get to use records. So, you know, literally a smattering of lines. And then second of all, if you're just managing one or two, just create a simple entity. I dare you. Try it out with JDBC and try it out with JPA, Spring Data JPA and Spring Data JDBC. Create one entity with one field, like ID and then name. So two fields, but one's the primary key. And then just, you know, use a JPA repository instead of list CRUD repository. I'll bet you it's almost twice as big if you compile it into a native image. I'll bet you it takes almost twice as long to start up on the JRE and in native as well, if you're using JPA. So for the small case, this is just way better, way better. It's simple, easy to understand, less code, faster, more performant. You're not paying like 50 extra megs of native image binary size just for Hibernate and all that stuff. So this is actually a really good deal. And you can see it scales up pretty well as well. So if you have more than a few entities, this will be okay. I haven't tried it with 100 entities, but I wouldn't want to either. Again, that's why this is to me the ideal toolkit to build microservices or even scalable modular monoliths. And by the way, you know what project this works particularly well with? Spring monoliths. Now, friends, I've got an application here, and this is, you know, it's fine. I've got Postgres, and as I mentioned earlier, we have things like Yugabyte that you can use and scale with great ease. That said, sometimes I don't want to like add undue stress and undue load to my systems, to my database. That's completely reasonable, right? I want that to be as fast and efficient as possible. So I'm going to want to introduce caching. And here, you know, again, another point for Hibernate and JPA is that they have this really, really sophisticated second level cache. It knows about your object graph, and it's undeniable that that could be very useful if well tuned and if you understand what you're doing. But we don't have that in Spring Data JDBC. There's no second level cache in Spring Data JDBC per se, but there is one of a sort. There's a memoization function. There's a caching mechanism in Spring Framework itself called the Cache Manager Abstraction. And there are a number of different implementations that you can use, including one that uses the JCache abstraction, right? So you can, if you don't find the implementation you want among the different cache manager implementations from Spring, then, you know, if you do find it from JCache, there is a JCache cache manager, so you can delegate to all that. So here's the few that I have in the class path, but if you had Apache Geode, you'd get one for that. If you had Redis, of course, you'd find one for that. If you had Gemfire, you'd find one for that. I think Coherence has one as well. I mean, everything for which it makes sense, there is one of these, okay? It's pretty straightforward. Give it a name, give me a cache region, and give me all the cache region names, you know? Okay, so we're going to use a cache manager here. We're going to tell Spring that we want caching. So I'll say enable caching. And then we'll define a bean of cache manager. So concurrent cache, map cache, concurrent map cache, okay. So we're going to define a cache manager. So it's going to be bean concurrent cache manager cache, return new concurrent cache manager cache, and we'll name it like this. We're going to say cache.set allow null values. Okay, sure. And cache.set store by value. Now, what is this? Well, it's going to serialize. If you do this, it's going to serialize the writes. It's going to serialize every object you put in the cache. So what you get back is not the live object that might be garbage collected or whatever. It's actually the serialized version of the object. And that's useful. Well, first of all, if you want to just have a flat cache flat representation of the data, untangled from your memory structures. That's one way to do it. The other is that it's great for us because we can test whether it's actually working or not, right? Because if it was just a regular concurrent map and I put the object in, well, then of course, if I get the object back out, I'm still dealing with the same pointer, aren't I? But here, if everything's working to plan, we should get a completely different pointer. It should be a brand new cloned version of the object, right? But that means that we actually have to have serialization. So implements serializable. Okay. Implement serializable and implements serializable. All right. So now there's our serialization. Great. I'm glad we did all that work. Let's try this out. So we need to actually tell Spring what to cache and how to do it. Thankfully, we can just add that to this repository. So let's create a cache key. String customer cache key equals customers. And then we're going to override the save method. Save, okay. And the reason we're going to do that is because we want to do cache eviction, right? So we want to avoid the customer cache key. We want to avoid the key here. Result. There. We want to avoid having the when we save it, we want to evict the thing that's in the cache so that when somebody reads it again the next time, they get the new fresh version. Okay. Okay. So there's that. Now, what about the find operation, the get operation? So find by ID, let's say. Or actually, let's just use find by name. We've got this one right here. So here, I'm going to say I want to have this to be cache a bowl customer cache key. Okay. So the parameter, the name, is going to be used to inform what data gets cached and returned. Okay. Maybe we'll do it by ID. That's more of in line with the contract. Okay. So cache a bowl customer cache key. Great. So now this will be, the ID will be used to create the key that will then look up the record in the cache region. Okay. But we haven't added this to the implementation. We didn't have to do anything. We just annotated our repository here. So now to prove that it's working, let's get this result. Okay. And I want to assert that the result does not equal the thing that we saved, right? So customer good. Okay. So let's try this out, huh? Let's go ahead and run it. Great. Now we can actually, it worked, obviously. We didn't get an exception, but let's debug it just to kind of see what we're getting here. Okay. So there's the result. The result is the collection. Oh, it's because I got a collection back, right? So that wouldn't have worked anyway. Okay, that's fair. So result dot find by ID. Okay. And here we'll say customer.id. So I'm going to find the result. The result is a single record that I'm going to get. Okay. And then I'm going to match it against the one that we put in there. Okay. So what's the issue? Two references should not be the same. I did a fool's mistake here, friends. This is equality of the data types, not the memory references. So there we go. They shouldn't be the same pointer. That's what I'm trying to prove here. There we go. So we can debug that again. Result is this one, right? We can see it's got this and 7379, and then customer is 7378. So two different objects. One was obviously cloned from the other. They're exactly the same, identically, in terms of identity, but they are different objects altogether. Isn't that cool? So we're actually getting a cached version of the object. Didn't have to go to the database for that. That's nice. If we look at the, we can actually do a quick test here. So let's get rid of that for a second. Getting hopefully cached version. Okay, so we're going to get it once, and then again, var result equals this. Okay, so now we're about to get a result, releasing JDBC connection. Okay, so you can see the first time we called the query, we got the results back. So let's copy that here. Here we go. This is the second time. 2, 1. Okay, so 2, there's no SQL here. It's just getting it straight from the cache. Isn't that powerful? That's amazing. Spring Data JDBC, I like it. I would start with this, and it's part of the stack. I'm really starting to like to use. I love Spring Boot, of course, so I use JDBC ORM solution, and Java OQ is great. MyBetas is great, and Spring Data JDBC is great as well. I use that, and I use Spring Monoliths, which is great for creating modular monoliths, right? You get nice clean componentization, you get nice modular architectural boundaries, you get opinions about architecture, whereas Spring Boot just gives you opinions about application. And then it's opinions about architecture for modular monoliths, not for distributed systems. For that, you need Spring Cloud. So both Spring Monolith and Spring Cloud build on top of Spring Boot, but they serve different use cases. And so if I'm building a modular monolith, I'm going to use Spring Data JDBC. I'm going to use Spring Monoliths. If what is old is new and so on, then maybe I'm also using HTMX. Maybe I'm not bothering with building a fully blown Vue.js or Angular or React front end anymore. Maybe I'm just using HTMX and rendering server-side HTML with Spring MVC and Timeleaf and all that. And again, now that I've got virtual threads, it's not really a problem to do it. I can actually do it. It's very quick and it's fast for the client as well. So anyway, it's an amazing time, my friends. JDBC is back. It's amazing. It's more amazing than ever. There's never been a better time to use it. And Spring Data JDBC gives you the best of both worlds. And remember, behind the scenes, you're just using regular SQL and you can kind of see what it's doing and you can work with it and such. This also works very nicely with things like Flyway and Liquidbase and so on. I haven't bothered to set that up here, but yeah, I'm sure you can imagine. It's easy. Friends, thanks for watching, and as always, we'll see you next time.